So most electricians assume LED problems can be fixed after install. In reality, LED linear lighting has a narrow decision window where longevity is determined and the window closes much earlier than people realize. And everything is fixable after, but there's a cost attached to it. And sometimes people say they're not footing the bill, or customers say they're not footing the bill, and they hold you accountable. So we've learned to filter out these problems so we don't have to address them after the fact. Once most fixtures are mounted and drivers are selected, brightness is set, and controls are connected, you're already locked in most of the thermal, optical, and electrical stress the system will experience for the rest of its life. Adjustments could be made later and can improve appearance temporarily, but rarely undo long term degradation. And what I mean by that is that, you know, dim things, adjust things so that it works, or just hack rewire some of the stuff. But putting in a robust system is what ensures that systems really last the test of time. And we've had installations over 10, 15 years still going with minimal replacement, such as a driver replacement, but the LED lighting system itself is really strong. And this those causes that I mentioned, and that's why the LED installations age badly, even to the point where nobody could point a finger at one single mistake, especially when you're centralizing transformers and you don't have the correct wiring in place. So understanding this decision window is what separates installs that survive from installs that slowly decline over time. If a decision affects heat, load, usage, it affects longevity, and it's usually made before the first power up. So before your next LED install, pause and write down these things. Where will the fixture live, such as the environment and location? Is it indoor? Is it outdoor? Is it indoor wet, like a spa room? So take time to understand the environment. Then start to think, how long will it typically run each day? Now, this is a big thing because people take residential grade, like LEDs, like a Home Depot bulb, and they put it in a commercial environment, such as a showroom. And these things will start to fail prematurely because they were only spec'd for residential use. So understand now, how long is it going to typically run each day? Think about whether the brightness decisions are being driven or expected. You're not fixing anything as yet, you're just identifying, you're building that mental framework of how to think, because this is a framework: A, B, C, D, E. So think of LED longevity in three phases: pre installation decisions, which lock in the lifespan and the right applications. Think about what I mentioned: how is it being used, how long, these things. The initial operation, which kind of hides the problem. So the customers tell you, I'm using it this amount of time, and then in actuality, they're using it 24 hours. And time exposure, which reveals the most problems over time. So these are born in phase one and then discovered in phase three. So this is the visual timeline of how LEDs problems show up. So there's a common misbelief, and it's something like, if something's wrong, we'll just change it later. Changing later affects your cost, it affects inconvenience, and it affects reputation. You want to do something, put it away, and build long term credibility and reliability. Now, this works for fittings if you have that mindset, like a screw based bulb. It does not work for cumulative stress in LED linear lighting systems because there could be many root causes of why things are happening. And even people who are using the high voltage systems, you have to deal with replacement parts. If something goes wrong, the lead time to get that specialized part, or the supplier may not even give you the option to get a part. They may say you have to put in the whole new thing. And then you have to do the warranty whole issue. You have to go do the whole warranty shindig where you document and try to get back your warranty and what have you. So we want to avoid these systems. So we've seen installs where brightness was reduced months later to address glare. I'm just giving you an example. But by then the project was finished and the client had to spend on wiring a low voltage dimming system. So they had to run two control wires to get that 0 to 10 dimming. Now the adjustment improved overall appearance, but it also pushed the project into cost overruns because that decision window that we're talking about in the beginning that sets up this framework was missed. So you don't need to become an engineer to protect longevity. You just need to recognize when decisions matter the most. And you could solve all this by understanding this framework we're about to teach.